Alan Turing, a pioneer of modern computing and artificial intelligence. His contributions to mathematics, computer science not only shaped the modern computer architecture, but also inspired so many technologies that we all rely on today. Alan Turing was born in London on June 23, 1912. From a young age, he showed a lot of really remarkable abilities in math and science. His curiosity and brilliance set him apart, where he quickly became known for his unique way of approaching problems. Despite his talent, Turing struggled with the rigid education system of his time and often felt it too focused on rote learning. He eventually went on to study at Cambridge, where he began groundbreaking work. Cambridge provided Turing with an environment that he could explore his interests in mathematics and logic, laying the groundwork for the revolutionary ideas he would later develop. In 1936, Turing published a landmark paper called On Computable Numbers with an Application of the Ishkenberg Problem. In this paper, Turing introduced the concept of what we now know as the Turing machine. A machine is a hypothetical machine that manipulates symbols on a strip of tape according to a set of rules. Despite its simplicity, this machine could theoretically solve any computation that a computer can perform today. This concept of a universal machine was revolutionary because it defined the limits of what a machine can operate. The idea behind the Turing machine wasn't about just creating a device, but understanding the nature of the computation itself. Turing's concept suggested that any problem that can be broken down into steps can be solved by a machine. This was the birth of theoretical computer science and established a framework for the computers that we use today. During World War II, Turing was recruited to work at the British government's code-breaking center. His mission there was to decipher German Enigma code, which was like a complementary encryption method used by the Nazis to secure their military communications. The Enigma machine was thought to be unbreakable due to its vast number of possible settings, which led to trillions of combinations. However, Turing developed a device called the bombe, which would quickly eliminate unlikely settings and significantly narrow down the possible combinations. Turing's work on the Enigma code was instrumental in shortening the war by helping Allied forces anticipate and counter German attacks. It's estimated that his contribution saved millions of lives and prevented years of additional conflict. In a very real sense, Turing's code-breaking showed the power of computation in real-world applications and illustrated how technology could be used for both intelligence and defense. It was a significant step in the evolution of computing hardware. While it was not a programmable computer in the way we think of today, it was one of the first instances of a machine designed specifically to handle computational tasks. It was operated by testing different letter configurations rapidly, something that would have been impossible for humans to do in a reasonable time frame. His work with the bombe demonstrated how machines could be created and customized for a specific, complex task. This concept was a precursor to the developments of a digital computer. After the war, Turing turned his attention to the idea of machine intelligence. In 1950, he published a paper titled Computing Machinery and Intelligence, in which he posed the questions, can machines think? This was a bold idea at the time, and Turing proposed what we now call the Turing test to answer it. This test involves a human judge having a conversation with both a machine and another human without knowing which is which. If the judge cannot reliably tell which is the machine, then the machine could have been said to have demonstrated intelligence. The Turing test has since been a foundational concept in artificial intelligence. While it is debated and critiqued, it still serves as a benchmark for testing machine behavior and intelligence. Turing's question of whether machines can think as relevant today as it was in 1950, particularly as we continue to develop advanced AI and machine learning systems. Theoretical work on computation also had significant influence on computer architecture. His concept of a universal machine laid the groundwork for what we now call stored program architecture, where both data and program instructions are stored in a computer's memory. This architecture was later formalized by John von Neumann and became the standard model for modern computers. In a Turing machine, instructions and data are not separate entities, which is a core principle of stored program computers. Almost every computer today follows this model, and Turing's theories remain at heart of the computer design. Despite all of his contributions, he faced persecution due to his homosexuality, which was considered a crime at the time in Great Britain. In 1952, he was convicted and sentenced to chemical castration, a treatment which was supposed to suppress his sexuality. This deeply affected him both personally and professionally, and later he committed suicide in 1954. It took decades for the world to finally recognize Turing's contributions and injustice that he suffered. In 2009, the British government formally apologized for his treatment, and in 2013, he was granted a pardon. His tragic end, the Turing legacy lives on. In 1966, the Association for Computing Machinery established a Turing Award, which is often called the Nobel Prize of Computing. This award honors individuals who have made lasting contributions to computer science. It's a testament to the enduring impact of Turing's work and serves as a reminder of his foundational role in the field. Still continues to inspire researchers in fields like artificial intelligence, machine learning, and theoretical computer science. Concepts like the Turing machine remain essential to understanding the limits of computation, and the Turing test is still referred to in debates about AI ethics and intelligence. Contributions to computer science, cryptology, and AI have left an unforgettable mark on our world. His vision and innovations laid the groundwork for the technologies that drive our lives today. Turing's legacy reminds us of the powers of curiosity, resilience, and the drive to push beyond conventional boundaries.